Welcome to another tutorial on MATLAB Tech. In this particular tutorial, we will be looking into three major aspects of this particular tutorial. How to create a system, which is basically a mass tempo system. Then we will look into detailed features of the scope, how we can manipulate the data inside the scope, and what are the available options that you can use to make your graph look good. And along with that, we will be discussing how you can export the data from the scope to the MATLAB environment. So to get the details of all these, please stay till the end of the video. And yeah, let's get started. Here we have the Simulink model, and in Simulink model, we usually need to develop a model, and then the model responses will be taken as an output, and basically we do plot it in some scopes, right? So here we have used a mass damper system. So how this system is designed, so let's see that first, and then we will be jumping into the related concept to the scope. Okay, so here we have a single mass damper system, and K is the spring constant, B is the damping constant, and F is the applied force. And suppose we do a free body diagram for this particular mass system, then mass into acceleration will be in the opposite direction to the applied force, and the B into velocity or damping constant into velocity will be the damping force, and Kx is the spring constant into the displacement. So this is the spring force that you have, and this is the overall free body diagram for the system. And based on this, if we try to derive the system equation, right, so in that case you will have F equal to ma plus bv plus kx, which is sum of all these against this one. Okay, and when you try to equate this, so based on this, a can be represented as a double derivative of displacement. So for individual derivative, we given points. So 1 point means one derivative, 2 points mean two derivative. So we transform the acceleration into double derivative of displacement with respect to time, and we transform the velocity into single derivative of displacement with respect to time, and kx will be staying as it is, and whatever the highest order term that we have, right, this one, so this we are shifting it to the left hand side, and remaining terms we are keeping on the right hand side. So based on this, we have the system equation like this, and that we have modeled in this particular model. If you are able to see over here, so F is the applied force, it will be multiplied with 1 by m. So F is the applied force, and it will be multiplied with 1 by m, and then we have this as the velocity, and here we have the acceleration, displacement. Here we have the displacement, and based on this, like, velocity will be multiplied with b by m, right? So velocity will be multiplied with b by m, which is x dot, and displacement will be multiplied with k by m. So here you are able to see, and both of these signs are minus, so here you are able to see the minus sign, and this is how we have developed the model. So this is not the major topic for this particular tutorial, but we will see the scope more. So regarding the plotting part, so we are plotting displacement, acceleration, and velocity, and there we are sending it as output from the subsystem, and we take the applied force as the input. So this is the force that is coming in and going inside the subsystem. Now we will try to simulate the model, and we have a scope over here. Okay, so that we will try to modify. So let's see like what are the options that are available for the scope. Okay, so we did the simulation is working fine. Okay, so over here basically when you see this 1 by m, k by m, and b by m, right, so these are variables. So where it is basically defined, so it is defined in file, properties, model properties. Okay, so here inside this callback I have defined it in the init function, and these are the values for the m, b and k. Okay, so let's get started with the implementation for the scope. So this is what about the model, and let's now start with the implementation. So here you can see these are the graphs that are you are getting, right? So the graphs are coming very cluttered. You are not able to recognize or distinguish between the graphs. So first thing you need to do is to give the name for the signals. So this is displacement, this is acceleration, and this is velocity, right? So when you resimulate it again, then you will be able to see these names. Okay, if I just double click on the scope, so you are able to see the names, but you don't know which one is which one, right? So for that, let's do some manipulation for this. Okay, so we have to choose the number of inputs. So here we do have 3 inputs, so that we already selected. Next is the tools or the views. So we can go to the layout in view, and here you will get the layouts. What are the different types of layouts that you want? And this is the layout. So we have 3 signals, so we will be choosing this 3 rows, and it will be adjusted based on that. So just trying to adjust. Okay, so all are having now yellow color. Previously we've seen different colors, right? So that is one part. Like now these are individual graphs, so that's why it is in different colors. But you are able to see, right, the displacement, acceleration and velocity separately now. So suppose I want to do the change in the color, right? So where can I do that? So you just need to click on right click over the any of the graph and click on style. Then this is the panel where you can change all the colors. So figure color and the axis color and all these things. So what we want to do, we want to paint the first one. So this is the display axis one, which means this one, and it is also highlighted, you can see. So here I want to change the color to maybe blue, and I want to increase the thickness maybe to 2. Okay, and when I press on apply, you can see the changes will be reflecting on this. And suppose you want to change the figure color, so it was in black, I can make it white and apply. Okay, so this will do the change over here. So black was better. Okay, and we can choose the access color and apply. Okay, so access are now changed, right? And also this one, suppose I want to make it in black color, so that you will be able to see it in a proper way. Okay, and yeah, so this is related to black, and then this was gray. Apply. So we are going back to the default setting because that was clearly visible. And over here you can also change the graphs, like you are into the second graph, you can see the second one is now highlighted. Now I want to change this color to maybe green and maybe 1.5. I want thickness. If I do apply, then this graph also got changed. And maybe I can do for the third one. Then this is maybe I want it as red, and maybe I want to. Okay, you can also change the line type, so you want dotted line or something like that, so this will be dotted line. Okay, so you have this setting, the first one, and the second one is related to logging setting. So when you do log the data, right, so which way you want to have it. So along with that, you also have a option of open at start simulation. So suppose you open the model, you just stimulated the model, but you want the graph also to open automatically. So you can check this box, and then the graph will automatically open when you do start the simulation. So that is one setting. And then coming to the logging setting, so suppose you want to log the data, right? So data will be logged into the workspace, and you can see the variable name. Okay, so whatever the variable name that you give, right? So suppose I want to give it a name as response. Okay, so response is my variable name. So I have multiple choice of data type over here. You can make a structure with time, structure, array, dataset. So by default we are choosing dataset, and yeah, clicking on apply and okay. So now I will just close this scope. Now let's simulate the model again. So whatever the setting we did for the scope, right, so those will be updated, and we selected open while simulation, right? So it got opened, and you are able to see the simulation in live, and it is now updating. And whatever the settings that we chosen, right, so those settings are being updated like individual colors, and this will be more helpful when you are trying to implement it in some research paper with different colors, so that you will be able to do the simulation in a proper way. Along with that, you also have a option for legend. So suppose you have more than one graph in a single figure, right? So here we are plotting it in different. So suppose in tools I go, suppose in view I go layout, and I select the single one. So all these will be combined, right? Now suppose I want to know which line represents which one, then I will go to view, and in view I want to make the legend turn on. So once this legend is turned on, you will be able to see the colors represent which variable. Blue color represents the displacement, the green color represents the acceleration, and dotted red line represents the velocity. So that is how you can have distinguishing between the plots. Along with that, suppose you are having the plot in a distorted way, like suppose you are simulating and you are stuck at some point, right? So suppose you want to zoom at particular point over here. So suppose I want to zoom in this area. So I did zoom, right? So the zoom happened, you did analysis. And with that, like you will have one more option called auto scale. So there are two types of auto scale. On the x-axis you have one auto scale, and entirely with x and y-axis you have an auto scale. Suppose you plotted a graph and the graph is not visible on your screen, right? So in that case, what you can do, you can just click on this second option, auto scale in x and y. It will plot everything in a detailed way, right? So that is how you can use auto scale to see your graphs and visualize the entire plot. Suppose you did zoom in a particular area, and then you want to see this. So you've seen this, like what is the value, and then you want to go back, then you can just press on auto scale. Then you will be able to come back to the original picture, which is the entire simulation. So this is what the major thing that you need to consider when you are dealing with Simulink scope. But we've seen one more option, right, regarding the data that we exported. So B and P out is the output. So here we have the response variable. right? So all the variables are stored in this one. So if you see, then you will find the signals. So first is the displacement, second is the acceleration, and third is the velocity. And along with that, you will get only the values, right? So if you just double click over here, then you are just getting the values. So values, okay, values with respect to time. So individual time you are getting, and along with that you are getting the values. Okay, data means value over here. And with this, like you will also get the time outside also. This t out is also the time, the simulation time. Okay, suppose you want to plot multiple variables, then you can do this by using this time variable. So x-axis will be time and y-axis will be any of the data that you want to plot. So suppose we want to plot the data, then in that case what you can do, you can type plot, and then in the plot, suppose you want to have the variable. Okay, so suppose you want to have the value. Okay, so this is the value for displacement, so we'll keep it here, and we want in this one only the second column and all the rows. So in this case, what you can have is the second column, so rows and columns, all the rows you want, and second column you want with respect to t out. So t out is present inside out. Okay, so what you can do, you can just drag it here. So out.tout. So if we do plot this, okay, so once you plot this, you will get the output index 2. Okay, let's see. So what we can do in this case, we can store this in a variable. So let's store this in a variable. So we have C as this. Okay, so C is a structure, and in this one I want to access the data. Okay, so C.dis is name. Okay, yeah, so we have the data C.data. So C.data we will be plotting in the response. So yeah, let's go to the plot command, and here we will just use the C.data. And you will get the graph. So what we did, okay, so we did something wrong. So we need to print the x-axis as time and y-axis as the data. So C.data. So now you'll have the graph. Yeah, so this is how the graph looks like, and this is how you can transfer the data from Simulink models to MATLAB environment and do the plotting. This is how you can create good plots from your model and put it inside your research paper. So this is all about regarding the scope and how we will be manipulating the scope in MATLAB environment. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. Have a great day ahead. Thank you.